So we can start this question by drawing the two functions given, f of x and g of x. So we have a parabola. So 9 minus x squared, it's a sad one, inverted. So it'll be like this. And we got a square root function, no reflections. It's going to be this shape, and it has just been moved 2 to the left. So therefore it'll be like this. So if we think about the domain and the range, so we'll just label this. So let's call this is f. So when I look at it, it'll be easy to see which one I'm using. So if we think about the domain, what am I doing? If we think about the domain of f, it's going to be all real numbers. The range is going to be negative infinity up to 9. For g, my domain is going to be minus 2 to infinity. And my range is going to be 0 to infinity. So find the rule for h, given that h of x is f of g of x. We can find the rule first of all. So here we're going to go, so f of x is 9 minus x squared. So I want to do f of g of x, which is the square root of x plus 2. So basically wherever I see x, I'm going to replace it with square root of x plus 2. And that's going to be squared. So when you're squaring a square root, it's going to cancel that square root. So I'm going to get left with 9 minus, it's just going to leave me with x plus 2. Important to put in the brackets there because we're taking away more than one term. Very easy to make a mistake if we don't. So then we've got 9 minus x minus 2. So our function h of x is going to be 7 minus x. So looking at the domain and the range of h, we're going to just draw my little sketch here, which will help me remember it. So start off with x. So when I'm doing f of g of x, the first function that you perform is g of x. So g. And then you perform the function f on g of x, and that produces f of g of x, which is h. So the way this works is we start off with just concentrating on the first part of the composite function. Start with the domain of g, and that maps to the range of g. And then the second part of the function is f. So that starts with the domain of f, and we're going to end up with the range of fog. So whether it exists or not is going to depend on this part here. So the domain of g, you'll see, is minus 2 to infinity. And that's given us out the range of g, which is 0 to infinity. We've then got the domain of f, which is r. And then we can't just state what the range is going to be at the moment. So this is going to exist, you see, because the second part of the function works for all real numbers. So there's no numbers that are getting produced here after g that are going to stop the second part working, because the second part works for all real numbers. So here the function is going to exist, and because the function exists, we can say that the domain of h of x, the composite function, is going to be then what we started with, the same as the domain of g of x. And we know that the domain of g of x, you see, is minus 2 to infinity. So that's what it's going to be. Okay, so thinking about the range now, it's a little bit more complicated. So the range here, we're thinking about the change that's happening here. So the domain of f, you're not putting in value of real numbers, because after the first part, you're not getting any negative numbers. So therefore, that changes the domain of f. So this is going to be what we're putting into the next part is just going to be what we're getting out of the first part. So the domain is going to change to 0 to infinity. So for f, we're just looking at f for 0 to infinity. So if we look at the graph for f, and we're just looking at 0 to infinity, we're just looking at this part here. And then here, this point here is going to be 0, 9. So if I'm looking at the range then the range is going to be negative infinity to 9, which is in fact the same, but not always. The range here of h of x is going to be negative infinity up to 9. Okay, because that is this section here.